Broadcast is now starting. All attendees are in listen-only mode.
Hey, good afternoon, everybody. Hope everyone's doing well, staying healthy, staying safe, and staying sane for that matter. It's always nice when the weather's nice, like yesterday here in the Northeast, you could get out. But rainy days are kind of a little bit more of a bummer. But anyway, hopefully this will be a little bit of a bright spot in your day. We're going to try and make it interesting and appealing. I thank everybody for joining. We're going to take a little bit of a look at the Creo Flow Analysis extension for CFD for Creo. So I'm real excited to have Paul Dye with us today, who's an applications engineer. And Paul is going to take us through a brief presentation as well as a demo. And we also have Bill Stickney on the line, who is a CFD and FEA expert. He's also a part of 3HTI and just a really smart guy. And we've been able to help a lot of customers with some CFD issues and FEA issues. So without further ado, I'm going to pass everything over to Paul. If you have any questions, please type them into the dashboard. And Paul, it's all yours.
Awesome. Thank you. And again, my name is Paul Dye, and I'm an application engineer here with PTC, primarily working with Creo. And that's what we're here today to talk about is Creo's flow analysis extensions. And this is something that we've developed over the past couple releases of Creo with our partnership with Cimerix. And I'm going to go through essentially a lot of the different capabilities we have with this. And just as a brief agenda, what we're going to be doing is first talking over some of the different challenges that we see out in the industry today when trying to work around things like flow analysis and how that relates to your design process. And I'll go through our solution to that with the Creo Flow Analysis extensions in Creo, go through the capabilities, I'll show a brief demonstration of it, and towards the end I'll talk about and really review some of the real advantages we get with that. And before I hand it back off to any type of questions or anything, I'll talk briefly over some of the packaging options that you have and some of the capabilities with each of those. So without further ado, we can jump right into it. And a really good place to start is by going over some of the different challenges that this really looks to address. When you think about things like CFD or flow analysis, it's typically seen as something that requires extensive training or knowledge that your standard engineer in general just tends to lack. And it's nothing on that, but it's just something that's normally fairly siloed, and normally it's the people that work with it a lot. And even if you are trying to go through and do this type of analysis, it tends to require the use of a third-party tool completely separate from your CAD tool that you're using. And most of the time, it's not only very expensive, but also difficult to use. That's because you have to take the models from your CAD system, export them, and then have somebody that has the knowledge on how to use the CFD tool to even begin an analysis. And this process can be very time consuming from start to finish, which tends to make this process only viable in the later stages of the design process. That's because in the development stages or even into the mid stages of your design, models are in a constant state of change. You're working with them, adding material, changing around where things are located, and you just can't wait around for the analysis results. You can't wait around. If you want to get something updated, it could take a full week to get results back. What we tend to see is this leads to an over-reliance on physical prototyping because you need a way to verify your design. This again tends to occur only later in the development cycle. It can be very costly if you want to go through multiple iterations. It can start to really pile up in terms of the time costs and even just the money spent on that. And this reliance causes projects to be delayed, come in over budget. And these are obviously things that we would like to avoid in our projects. All these challenges are things that we set to solve with the flow analysis extension in Creo. So the goal here of this extension really is to take those fluid dynamics capabilities and put them in an easy to use tool right within the CAD environment. So no more heavy reliance on late stage prototypes or other verification techniques. You really want to make this a part of your early and full design process and get those results back a lot earlier on and often throughout this process. To start, we built this tool to be utilized by everybody, not just the expert or the flow analysis specialist. We want our designers, the people actually building these things, to be able to work with this extension and build that into part of the overall process of the design. And this workflow between our design and our flow analysis in Creo is seamless. Compared to your normal process of going from the design, transporting out to a third-party system where you might have translation issues switching between your CAD and your analysis environments. We've broken down that barrier between those two different worlds, between the design and where you do your analysis. This is really more one unified analysis-driven design environment. We also have very easy flow model creation. So for example, here we have the ability to tell the system to generate the mesh for our analysis. So we don't actually have to go through and manually define that all for ourselves. So we still do have the ability to make the mesh more refined in areas where we might want to have, if we have some complex curves or surfaces changing, we make the mesh a little bit more complex. In areas with more simple flat geometry though, we can expand out that mesh a little bit more to run faster. And these are all things that Creo can just do automatically for you. Along that train of thought, this tool has a really quick turnaround for getting the simulation results. So it's no longer shipping off our models at the beginning of the week and hoping to get results back by the end of the day, by the end of the week. Let's just go through, run that analysis by ourselves, and still get the results back much faster. And in conjunction with that speed though, the results that you're getting back are still very highly accurate. We have lots of different ways of viewing the results, analyzing that, taking section views of the models, creating XY plots, seeing these ISO services, seeing how things are actually working in your design. So with that, you're not only getting the results, but getting it into a form that actually provides insight rather than just a bunch of data laying around that you might try to sort through, something that's very visual, something that's easy to understand right in that same user interface that you're used to right in Creo. And mentioning on that, let's switch right over into Creo so we can actually get a idea of what this looks like here and what it looks like to go through that general process of laying out one of these flow analysis studies. Right. So here for our demonstration of going through and working with the flow analysis extension here in Creo, I have the part or the data set that we're going to be working with. So specifically, we want to get some information on this heat exchanger. So this is actually a snowmobile from one of our customers, Polaris. And this is what we want to look at here is actually this heat exchanger in the middle of it. So we can simply open up that part and get working. All right, we can see we have some pretty good geometry in here that we're going to be able to utilize for the study. We know that we're going to have some water moving through this heat exchanger. So we can go through the process of setting that up here. The first step that we're going to do is go up to the top into our applications and select our flow analysis to get going. And now the very first thing that we'll go through and do is lay out a new project that we're going to get into. Once we have that and we're ready to go through and lay everything out, we'll first lay out our fluid domain for the study. So the fluid domain is the boundary of the simulation. It means that all the fluids within the study are contained within that 3D space. The other thing we can do here is lay out a surface set that tells the systems where our openings are located. In other words, where the fluid is either entering or leaving from the system. And after we've laid out that fluid domain, there's obviously going to be parts of the model where fluid's not going to be flowing through. So here, we're just telling the system which parts of the model should be treated as solids and then excluded from the study. After that, we can go through and define some of the materials for our study. And around that, we have two main areas that we define. So first, we have our fluid domains, or in this case, it's set to air by default, but we have a lot of other options that we can go through and choose here. So we have things like argon, chlorine, anything really that you work with, you can go through and select from these options here. In this case, we know we're going to have water moving through there. And on top of that, we also have our solid domains that we want to lay out. So whatever this actual heat exchanger is made of, in this case, it's going to be some aluminum 6061. With that, you can also work with, it's really just a standard Creo library of materials that you have there. And you can still go through, and if you have a material that's not within that standard library, you can still add that in, just type in any of the values associated with it, anything that you work with in your systems, go ahead and work with it here in the flow analysis as well. So that looks good. Now the next piece here that we want to look at is our physics modules. What this is laying out what we want to study, essentially what type of things that we want to go through and look at. In this case here, I want to look at things like turbulence, heat, streamlines, and that's it. That's all I want to select here for this case. Because if I don't need to go through and look at things like radiation or multi-phase cavitation, that kind of thing, then we simply just don't select it. And then we don't have to go through and find out all those results. It's just really optimizing for specifically the modules that we want to look at. If it's turbulence, if it's heat, streamlines, let's focus in on those in particular. Now that we have that laid out, we'll take a closer look into some of the conditions for our analysis. And this is really extensive. So for our study, we can see maybe what our minimum and maximum temperature values are going to be. You can see down here, we also have some options to plot our outputs, but we can see more of that in a minute. Now, the next spot that we want to take a closer look at is our boundary conditions. So let's zoom in here on our inlet pipe. We can go through and enter some of the values that we want to observe, such as the inlet flux and the temperature associated with that. There's really a ton of different parameters that can change here, really tailoring the analysis to the exact case that I want to study then. And we can do the same thing down here at our outlet. In this case, I think we're pretty much happy with most of the values down here. Maybe we know that the exchange coefficient and the ambient temperature, or what that's going to be for our aluminum heat exchanger. So very quickly, just go through there, define some of those values for that model. And once we have all that added in, we can go through and generate the mesh. Again, this is something that Creo can do automatically for us without us having to really go through and work with it and try to really optimize it around exactly what you want, which you still do have the option to do. If you want to go through and play with it and build it out in the way that you want, you still have options to do that. But in a lot of cases, this automatic mesher is really going to build out some awesome geometry. In this case, we can go through and take a look at what that looks like. Like I mentioned earlier, in areas where it's going to be a bit more complex, so you have some curvature, it's going to build out the mesh to be a bit finer in those areas. And then any area in the middle, like you see there, where it's going to be a bit more flat, a little bit easier to approximate, it's going to start to spread out that mesh a little bit more. That's what you want. It's going to make our study go through a lot smoother. And so after we're happy with that, we see our mesh, we can simply go ahead and click to run our simulation. You can see essentially as soon as I click that button to run the simulation, we're getting data back from our study. And I'm able to make changes to the animation style and putting it into a form that best displays the information that I want to see. And then looking at our plots at the bottom, we can see maybe around the temperature, settled out just around 360 degrees Kelvin. You can also see for each iteration we go through, our plot information is being updated real time. And this all took us less than 3 minutes to set up, and we're really getting the results back that fast. And once we have that completed analysis, we can go through and see what we got. And just looking at this, we can see the water's coming into the heat exchanger at its highest temperature, and as it's moving through, it's cooling down by the time it gets to the outlet. So everything seems to be working pretty much as I intended, but we can take it a step further, analyze on other outputs such as pressure to see how that's changing over the course of the flow. Maybe we need to see the effect of the temperature on the outer casing of the heat exchanger as a result of that flow. And actually, it kind of seems like an issue there, actually, because there seems to be a bit of a dead spot in the middle where everything's flowing around the outside, not really affecting the inside. Seems to be a bit of a dead spot, which maybe that's good for my case, maybe it's not. But now it really gives us insight into that. It gives us a much better understanding of what's happening in that process without me having to send these things off to the specific analyst. And one of the other useful tools I have here is the ability to take section views of the results. So say we want to take a look at some of the temperature values inside the model, well, we can move that to the X-plane and the Y and the Z, really wherever you want to look. On top of that, we also have another tool at our disposal for looking for specific values throughout this simulation. If I want to do that, first we have a slider bar that we can essentially move from a minimum to a maximum and see where those values are in the model. If I wanted to see everywhere where we had a very particular value, maybe 345 degrees Kelvin, I can type that in, see it right on the model there. And so that works very well for that. But one thing that also might happen in this is, like I mentioned, since we're working on this throughout the design process, maybe someone on my team sends us over a new version of the model. Says, hey, Paul, we developed something that we want to try out and see what it looks like. In this case, they built out more of a lattice type structure. Okay, well, that's definitely going to change how the heat exchange is going to work. Well, do I have to now go through and set up an entirely new study? No. All we need to do is go through, open up, and utilize the one we already created. What we can do is simply update the study to recognize that new geometry that we've added into the model. and also update some of the surface sets that we have to include the faces around both the inlet and the outlet for that fluid flow. And finally, let's hide some of those CAD bodies, utilize the mesh that we have there, and go ahead and run through the analysis. And then again, pretty much as soon as we click to run the analysis, we're instantly starting to get back meaningful data. You can see what that's doing, and we can change around any of our properties to get the flow into a form that makes the most sense for us. All right, and so looking at some of our flood information below, we can see that it's starting to go through an update for the more iterations that we go through and run. We're beginning to converge towards more accurate values for things like pressure, temperature, velocity, and looking at the model itself, you can see what that's doing. Looking how this lattice has certainly made a difference in terms of the values that we're getting and how it's moving throughout this model. So it certainly made a difference in terms of the direction of the flow, probably spread out that temperature gradient a bit more. And so as it's nearing the completion here, just going through and taking some of those last iterations. All right, and so our simulation's complete. And once it is, we have the ability to go through and do the same thing as before. Observe the flow a bit closer, click through to see any of the properties that we're concerned with, and start to analyze it. Look at our pressure, see how that's changing over the course of the flow. And then finally, let's take a look back at our temperature values, see if we started to spread out that bit. And definitely there, much more different than we had before, where we kind of had that dead spot in the middle. With this now lattice type feature that we've added in, it's definitely spread out that temperature gradient. It's a bit more evenly spread throughout this design. And that's what we want, is be able to do this, build out new features, try new things, be exploratory, and then get that instant insight into what that means for our flow analysis. Okay. Now, obviously with this, a lot of advantages and really a lot of value that it provides. Now that we've seen it in the context of Creo, you can kind of see more how it's working towards that analysis-driven design process. We're now able to run these studies much earlier on in the design process, and what that's doing is shaping our ideas moving forward. It's not really as much of a validation anymore, which it still works perfectly well as, but it can start to actually drive the decisions that we're making. And that's helping to break our dependence on those late stage physical prototypes. That's reducing both the costs and also the time to market. And that's due to the fact that we've gone through many more iterations on this virtual prototype much earlier on in the process. It's not these two separate worlds that we have to bounce back and forth between. We can do more of an analysis-driven design throughout that. And what it really boils down to is we're now creating and starting to innovate at every stage of the process. And the products that we're creating, and they're going to be coming out much more often at the highest quality possible. And that's because we're able to really do our due diligence and see exactly how our designs are performing. Okay, and so that is our general overview. And briefly, I do want to stop over and look at some of the packaging options around this. So depending on the level or different options that you might require for your processes, that can help you decide exactly which version of this you want to work with. So here, if you're focused on just the flow, some of the heat transfer, or even looking into turbulence, the base flow analysis might be your best bet here. So we can see some of those options here, some of the capabilities that it gives you. And then moving on, there's the second level of this, where if you want to start to analyze into elements like individual particles or radiation, these are things even like moving or sliding meshing. That's something that we could move up to the plus package. We can see and simulate the movement of individual components, along with also animating the analysis even while it's running, like we saw throughout the demonstration. And finally, if you're going to be working with dynamic models or multi-phase or multi-component systems, then you'd probably want to utilize the premium package. That gives you really the full scope or breadth of the capabilities with the flow analysis extension. So you get capabilities for cavitation, simulating fluids and solids interacting. It's really the complete fluid analysis solution that we have here and have the ability to provide you with that. So these are the base options here. We can see some examples of what's possible with the tool here. So like I mentioned at the beginning, this is something that we partnered with a company called Cimerix to create this tool for working within Creo. So if you're interested in seeing some of the different applications of this engine, they actually have a gallery over at cimerix.com that has a number of different examples of how the flow analysis extension can be utilized. And they're actively working on this all the time. This is something that has really been successful within Creo. A ton of different customers are getting a lot of good use out of this and constantly being updated with each new release of Creo. This is going to be something that is on the forefront of our development. And so with that, I can pass it back over to you, Rob, and we can take any questions or field anything that we'd like to elaborate more on here.
Sure. I'm going to ask you just to keep the screen up while we handle any questions, and I'm actually going to ask Bill to give some of his 2 cents in here too, because we had formerly represented a product called Flow EFD for Mentor Graphics, and this product right here is, I think in some ways, according to Bill, is actually better than Flow EFD. It actually has a better price tag, and there's a lot you can do with it. And I like the fact that there's 3 different packages. So with Flow EFD, it was just, hey, this is Flow EFD. Either one or you don't. It was pretty expensive. But for this, there's 3 different levels based on what you need to do. And I know for one of our customers about 2 years ago, we were able to assist them because it took them 2.5 to 3 weeks to run a flow analysis and to basically purchase a product like this where you could just run that analysis and complete it within, I don't know, an hour or less. Was pretty amazing. And I think, obviously it's clear the more you can do up front in design when you're designing for form, fit, and function, that's going to save time downstream and you're going to get your products out the door faster. So I'll defer to Bill what his thoughts are on these different packages and what are the best applications for these.
Well, this tool does things that are kind of unique in the market, at least for an interactive style tool like this, which is the multi-phase and also the dynamics, which means you have a model with moving parts. So you could simulate valves and pumps. Some examples here, there is a gear pump example they have also. Not too much else that will do that unless you get into an extremely high-end expensive code. So it's a bargain if you need to do those kinds of problems. However, a lot of our customers are doing somewhat simpler stuff, electronic packaging and heat flow analysis, which would include, by the way, natural convection. I don't think we saw an example of that. This tool does natural convection just fine. Just have to give it a density gradient and it goes off and everything works good. That type of analysis can be done with the lower end version here, just the basic Creo Flow Analysis. And it is considerably cheaper than some of the competition because they're adding a lot of other stuff in their package that you don't necessarily need. So for the electronics guys, that low-end tool is very attractive. The only thing it is missing is radiation. If you are dealing with basically infrared heat flow, you would need the mid-level package, the Flow Analysis Plus, and it does it fine, but not everybody in the cooling business needs radiation. That's more typical in high temperature stuff, or if you're dealing with spacecraft where there's no air, that sort of thing. So it kind of gives you the option of spending what you need and not getting hit with a very high price for stuff you may not need. So I like the way it's packaged, and I found the software to be accurate and easy to use, as you see. There's no big surprises here. It works dandy.
Well, Bill, if you endorse it, I'm on board too. Yeah, this is a pretty tremendous tool, and if for our audience, if you want to do a deeper dive and get into specifics about what you're modeling, what your products are, and what results you need to see. We could set up a 20-minute, half-hour call, whatever you need it to be. It could be an hour. You can get Bill on the phone and help do more of a deep dive into what problems you're trying to solve. So a question just came in that asks, if one has no CAD model, what are problems? Can condensation be addressed in a heat exchanger with water trained in steam? So this product does work with CAD. So you're going to need a CAD model, CAD package to hook up Creo Flow for it to operate. And I think the question here, Bill, is can condensation be addressed in a heat exchanger with water entrained in steam?
I think so. First off, we are capable of doing multi-phase analysis. This is liquid and gas. What you typically would do there is treat the water droplets as particles. I think you basically pretend they're solids. And you can indeed model particle streams, and the size and density of the particles are taken into account. So if you go around a corner, it will the particles will adhere to the wall and disappear out of the stream and things like that. So I think it can be addressed. We'd want to do a more specific example to get a confidence level, but I'm fairly sure it will do that.
Next question is, what is the typical time to come up to speed for beginners in using Creo Flow?
We will typically do about 2 days worth of training. It's typically done online and usually with the customer's own hardware if possible. Their own design, I should say. There are some tutorials available. You can work on those, but there's nothing like working on your own stuff to learn it. But it's not long. It's, usually about 15, 16 hours worth.
The other thing that for this to just relate is sometimes there's companies who have projects and they need to run a flow analysis for a project. It may be a one-time project. It may be something they only do once every couple years or whatever. And there's one or two things that you can do. I mean, if you want to buy the software, you can buy the software, or the thing that you can do is you can have us do the analysis for you. If it's it's one of those things where even though it's a tool that's easy to use, depending on the amount of frequency in using the tool or your need, you could also farm out your flow analysis or CFD needs to 3HTI, and we would put Bill on it and get that done for you. So then that way that creates an option where you don't need to buy an annual subscription. You can have us do the work for you. And if you need us to do the work, I mean, obviously we can we can use the the highest level of Creo Flow Analysis.
Yeah, because the previous question was particle behavior, which is the mid-level. That's a fairly common problem, actually. Anybody that deals with dust or actually, vapor droplets is a fairly common thing that I've run into. But we got all the goodies, so we can do whatever you need.
Yes, we do. Yes, we do. Cool. Well, I want to thank everybody for being on. And what I'm going to do is I'm going to share my screen real quick, if I can. Here we go. Oops, got the questions there. So anyway, if you have any further questions and want to get in touch with us, you could just respond to the emails that were sent for the for the invitation for the webinar, or you can, email us at info@3hti.com. That's real easy to remember. And, we're more than happy to give you more information and more detail on this Creo Flow product. It's like Bill said, it's a great product. It does a lot. It's reliable, and the results are reliable. And once again, it's putting everything in the hands of your designers and engineers to help design for functionality, so that you can get your product out the door faster and reduce the amount of rework and scrap and anything else that's going to delay your project getting out the door. So your product's getting out the door. So once again, Paul Dye, great job on the demo and the presentation. Bill, always great to have you on the panel. And want to tell everybody, stay safe and have a great weekend. And we're dismissed.
All right. Thank you. Have a good one.
Thank you, Paul.